question 4. All right, we'll get the screen. Is that okay? Right, so question 4, you have y is equal to root x times 2x minus 1. And what I always do for these is write the two functions over here. So u is always your first function and b is your second. And I don't know if any of you watch the videos, but rather than writing du dx, it's actually just quicker to write u prime. Now, first of all, to change this to a power of x, which is x to the half. So then this would be bring down the half and then subtract 1 to get your new power. And then using your rules of indices and powers, you change that back. So it's 1 over, the minus means it's 1 over, and then the half means it's a square root. Okay, so that's u prime. And then v prime is just bring down the 1, you've got 2 times 1, and x power 0 is 1, and the constant will disappear. And now using our product rule, we have crisscross, so it's uv prime, so that's 2 root x, plus vu prime is 2x minus 1 over 2 root x. Okay, is that all right, everyone? And then it says write that as a single fraction, so I need to put it on a common denominator. My denominator is 2 root x. So this first one here has to get multiplied by this. So do the numbers first. 2 by 2 is 4. And root x by root x is x. And then you have another 2x minus 1 is the second fraction. And then you combine those, and you've got 6x minus 1 over 2 root x. Yeah? Yeah. No, because it's 2 root x by 2 root x. And if you remember our SNL, 2 by 2 is 4. And then root x by root x is x. Okay. I think I can't remember, I may have scribbled out 2x and was doing very quick in the video. So. Okay, and then question 5. Is that okay for everyone?
Yeah.
My question 5 is, I'm sorry, I should write dy dx there. Now to you guys for not doing that, and then I'm not doing it myself. So y is equal to root x plus 4 times root x minus 4. So dy dx. So u is root x plus 4, which is x to the power of a half plus 4. And b is root x minus 4, which is x to the power of a half minus 4. So u prime is, and I could go through the whole thing here. It's the same as we just did here. So it's 1 over 2 root x. Okay, the 4 is constant, so its slope is 0. A constant line is horizontal, so its slope, or its dy dx, its rate of change is 0. And then the same here, I've got 1 over 2 root x for b prime. Is that okay? So then dy dx is crisscross, so it's root x plus 4 is u over 2 root x, plus the other one, root x minus 4 over 2 root x. And because we have a denominator, we can just add the numerators. So you've got root x plus root x, so that's 2 of those. And you've got 4 minus 4 is 0. And then your denominator is 2 root x. And that's one thing over itself, which is equal to 1. Okay? Now, the next thing we're moving on to is the chain rule, which I want you to really focus on this, okay? It's, people get kind of their heads in knots over this, and there's no need to, but you want to get it straight from the beginning. So we'll go through a few examples, take it easy, and I want to make sure we get this right. So the chain rule is when you have a function of a function, okay? And what we call that is a composite function. So I'm just going to write down the 3 examples and just go through why they are composite functions. So just looking at the 3 examples they give, basically when you think of a function, we often think of like this kind of black box. You put in x and you get out y, okay? And in here does something to x and you get out something else, okay? We call that y. So in this case here, it's a composite function. It basically means you've got 2 boxes. You start with your x, you go into the first box, which is 1 minus 6x, okay? So that's function number 1, and you get out 1 minus 6x. And then you go into the second box. So this is saying 1 minus 6x, and this is saying square. So in the second box, the function is square. Does that make sense? It's square the input. So your first function is this thing in brackets. When you've worked that out, then you do it to the power of, actually, sorry, it's power of 4, so it's not just power of 4. Okay, is that all right? This one, you would start with x, you go into your first box, and you come out with 5x plus 2. And then you go through your second box. So the input to the second box is the output from the first one. So this is your first function is 5x plus 2. Your second function is square root. So you come out with the square root of 5x plus 2. In this one, we start with x. We go into our first box. We come out with 3x squared plus 6. And then you go through your second box and you get the cubed root of 3x squared plus 6. Right? So you've got 2 different functions going on. This is your first function. The second function is something to the power of 4. First function is 5x plus 2. Second function is square root. First function is 3x squared plus 6. Second function is root 3. Or cubed root of that, sorry. Is that making sense so far? You understand what a composite function is?
Yeah.
Everybody okay with that? And what we do here is, what we're going to do is we're going to give a name to the first function. Okay, so instead of y being a function of x, we're going to just take what this is and we're going to call this u. And then when you put u in here, you get a, so say for the first one, you've got x and it goes through here and you get out u. And then u goes in and you get out u to the power of 4. Okay, now u we know is 1 minus 6x. Does that make sense? In this one, the second one, we put in x, we get out u. U is the input then, and we get out y is the square root of u. And we know that u is 5x plus 2. X in the first one, we get out u, which we know is 3x squared plus 6. The second function is the cubed root, and we're just saying of a plane. So instead of having something complicated here, we just have a simple, which stands for a function, okay? U depends on x. Is that okay?
Yeah.
So we're just writing that as u to the power of 4, where u is equal to 1 minus 6x. And here we're saying this is square root of u, where u is equal to 5x plus 2. And this one we're saying that's the cubed root of u, and u is equal to 3x squared plus 6. Okay, so u is your first function, and then this is what you do to u to get to y. Is that making sense for people? Anybody not sure? All okay?
Yeah.
Okay, good. So composite function, you do one function and then the other one, and we call the first function u, and the second function then is just whatever is left, okay? So just to turn over the page. So for example, 3x4 cubed, we could differentiate that by multiplying out the whole thing, but that's going to take a long time. So once you have complicated functions, you don't want to have to work out the whole function before you differentiate it. What we can do is use the chain rule. Okay, and the chain rule is basically let the first function just be u. Okay, and then what we effectively have is a product. So, for instance, if y is equal to 3x minus 4 cubed, okay, I let u equal to 3x minus 4, and then y becomes u cubed. That makes sense?
Yeah.
Then u depends on x. So u dx is equal to 3, okay? And y depends now on u. So dy du is equal to 3u squared. Is that okay? So I'm just using the letter u instead of x here, but otherwise I'm just using my normal rules. And what the chain rule tells us is that dy dx, which is what I'm actually looking for, is you're basically splitting it up. So you're having the dy over here and the dx over here, and you stick the du in above and below, okay? And if we look here, dy du is 3u squared, and du dx was 3. So my answer is 9u squared. And then at the end, what you do is change back your u. So you've got 9 times 3x minus 4 squared. Okay, so the thing with these is, again, we go over to the right, we put the, whatever's in brackets, the first function is u, and then y will be that cubed, or that, whatever's going on there. And then you differentiate the u with respect to x, the y with respect to u, and then you multiply. So all you're doing then is multiplying these two, and then you sub back in for u. So I'm going to go through the to an example 3. So y is equal to 2x squared minus 1 cubed. So I let u be what's in the brackets. And then y is equal to u cubed. Is that okay?
Yeah.
And then du dx is equal to 4x. That's easy enough. Dy du is equal to 3u squared. Is that okay?
Yeah.
Then you can either sub back in now, or you can do it at the end. So dy dx is equal to these two, basically. So 4 by 3 is 12x by u squared, and u is equal to 2x squared minus 1, and that's squared. Okay, or you could change this here as 3 times 2x squared minus 1, and then you multiply these two, and you 4 by 3 is 12x by 2x squared minus 1 squared. Okay. Now we do the next one. Y is equal to the square root of 3x squared minus 2. So u is, the first thing you would do is 3x squared minus 2, and then y is equal to the square root of u, and we need to write that as a power so that we can use our rule. And then du dx is equal to 6x, and dy du is equal to a half u to the minus a half, which we now know is 1 over 2 root u. And we can change that straight away back into square root of u is the square root of 3x squared minus 2. And then we just multiply these. So dy dx is 6x multiplied by, so we're dividing over 2 times 3x squared minus 2. And we can simplify that a little bit more, because 6 over 2 is 3. So that's 3x over the square root of 3x minus 2. Okay, so you just write down your two, you have a u and a y. Okay, once you decide what u is, you can rewrite y in terms of u. And then you differentiate the u with respect to x, the y with respect to u, and you multiply back the answers and sub back in your u. And that's the chain rule. Later on, when you get good at it, you'll be able to kind of skip all this and jump straight to here, but we're not going to worry about that just yet. We're just going to practice for now. Okay. Here they are saying let's jump. Okay, let's do 1 or 2 practices before I show you how to skip. okay? Because I want you to get it straight in your heads first, all right? So let's just do question 7 and do 1, 3, and 5, and then question 8, do 1 and 3, okay? We'll get started on those now.
What were the questions again?
7 and 8, so it's the odd parts in each of them.
Right.
Let me know if you're struggling.
Could you just go through the first one, please?
Yeah. So I'm just going to write it down and then I'll get rid of the book. So just bear with me. So y is x plus 4 squared. So what's u going to be? So but yeah. And then y would be, yeah, okay. So now, once you've sorted that out, you go ahead and differentiate. So we differentiate this one. This u is a function of x. So we can differentiate it with respect to x. There's no point doing du dy or du dt or anything else. It's u on the left, x on the right, so it's u over x. And when we differentiate x, we get 1, because we bring down the 1, and then the new power of x is 0, which is just 1 anyway. This is a constant, so it disappears. Dy, and we're different, it's not u now, this is in terms of u, so we have to have our letter here corresponding to this, which is u. Bring down the 2, take away 1 from 2 to get your new power is 2 to the power, okay, so that's just 2u. And remember, u is equal to x plus 4. Okay, so I just sub it back in. And then you just multiply these two together. So dy dx is just 1 times 2x plus 4. So that's 2 times x plus 4. And most of the time, we don't even bother to multiply that out. But if you did want to, 2x plus 8. Okay? So you're kind of just covering, you're saying, okay, what's in the brackets? That's your u. And then what's happening to that? It's getting squared. That becomes your second function. So the first function is, what would you do first? I'd do x plus 4 first. Then what would you do? I'd square it. And that's what that is. Doing okay?
Yeah.
Anyone getting stuck on any of them?
I just want to do the end of part 8, 1.
So you've got root 4x plus 1.
Like at the very end, I don't know how to put it into.
So let's see, y or u is equal to 4x plus 1, y is equal to u to the power of a half. So du dx is 4, dy du is 1 over 2 root u. So that's 1 over 2 root 4x plus 1. Okay?
Yeah.
Okay, and then you're going to multiply that by that. So 4 times a half is 2. So your answer dy dx
Oh, that's
by 1 over 2 root 4x plus 1, and then that's just 2 over root 4x plus 1. That makes
so you
sense?
don't do anything to the bracket.
No.
Okay.
The 4x plus 1 is under the root, so you're just doing 4 over 2. You can simplify that, but this has to just stay there. Is that okay?
Yeah.
Good. Anyone else? So I'm not going to go on to the next part for now, but I'm just going to give you also questions 10, 12, and 14 for homework. Okay.
Miss,
Yeah.
do you have any idea what's going to be on the summer exam?
I thought I put it up. Sorry, hang on. I'll just check. Oh, sorry. I've summer test. Sorry. I think the reason I'll post what I have now is just putting up more revision notes on, but I'll stick it up for you now. It's not quite done yet because I wanted to just put in all the revision notes on each topic. But it's basically Tuesday, May 26th from 2 to 3:30. So I'll put up the full test about 5 minutes before that so you can print it out. Or if you, and what I also do is put up a short one. So if you just want to keep it on your screens and do it in your copies, that's fine as well. And then allow maybe 10, 15 minutes after for you to upload it afterwards. So it's going to be chapters 4, 5, 6, and 7. So that's coordinate geometry, the line, probability, geometry, and what we're doing now, differentiation.
Would IXL help at all in terms of study?
Yeah, IXL is really good. What I'll do is I'll put in brackets after each of those what the IXL kind of parts are, if that helps, yeah?
Yeah, thanks.
Okay, yeah, I'll do that then. And I'm just going to put up today's assignment as well. Questions 10, 12, and 14 that I'm also giving you. You're going to work out dy dx, sorry, in 10 and 12 anyway. So you just do dy dx like you're doing, and then after you work it out, you sub in the value for x that's given. Okay, so it's the exact same as what you're doing. It's just after you work it out, you sub in the value that they give you for x. Okay. And question 14 is just a little bit of rearranging. Express y in terms of x, so bring all the x's over to the right hand side. Actually, are we going to be able to do that? Yeah. It's not quite chain rules, so, but it's a little bit of good practice in algebra, okay? And I'll do them out as well and stick up the video. So are you all getting the hang of these okay? Checking your answers? Sure you're doing them right. I mean, a few more submitting homework last night, but there's still a lot of people not doing their homework or not sending it in to me. I need to see homework. Part of your grade is also going to be on the effort you've made over the last couple of months. Okay, guys, if you're happy enough to keep working on that yourselves, I'll head off. But if anybody's any questions, ask me now before I go. Anything else? Okay, good. We'll get videos up as well, and just going through the steps and with solutions too. Okay.
Thanks, Miss.
All right. See you tomorrow, lads.